Hello, Miss Thinker here, your daily source for mind-blowing facts, forgotten history, and powerful motivation. Today, I will talk about the biggest explosions ever recorded in space. Have you ever looked up at the night sky and felt a sense of calm? A vast, silent, and unchanging darkness. But what if I told you that this apparent peace is an illusion? The universe is a place of unimaginable violence, home to explosions so powerful they defy comprehension. Today, we're going on a journey to witness the most powerful explosions in the cosmos. Our story begins with something familiar, a star. But not just any star. We're talking about stars many times more massive than our own sun. For millions of years, they burn brightly, fusing lighter elements into heavier ones in their scorching cores. This process, nuclear fusion, is a delicate balancing act. The outward pressure from the fusion reactions counteracts the immense inward pull of gravity. But this balance can't last forever. Eventually, the star runs out of fuel. Its core, now mostly iron, can no longer generate energy through fusion. Without the outward push, gravity wins. In less than a second, the star's core collapses catastrophically. The outer layers come crashing down onto this incredibly dense core and then rebound in a spectacular fashion. This is a supernova. A single supernova can outshine its entire host galaxy for a brief period, releasing more energy in an instant than our sun will in its entire 10 billion year lifetime. The shockwave rips through space, seeding the cosmos with heavy elements like gold and platinum, the very atoms that make up our planet and even ourselves. So in a way, we are all the children of these stellar explosions. The next time you wear a piece of gold jewelry, remember it was forged in the heart of a dying star. Supernovae are mind-bogglingly powerful, but they are just the opening act. Let's turn our attention to something even more extreme, a hypernova. A hypernova is what happens when a truly colossal star, perhaps more than 30 times the mass of our sun, dies. These are the titans of the cosmos. Their collapse is so complete and violent that it doesn't just result in a neutron star, it forges a black hole. As the black hole forms, it begins to devour the surrounding stellar material. This process isn't neat. It's a chaotic, swirling mess. The intense magnetic fields and rotational energy of the newly formed black hole can launch two incredibly powerful jets of matter and energy, screaming out from the poles of the dying star at nearly the speed of light. If one of these jets were pointed at Earth, even from thousands of light years away, it could potentially strip away our ozone layer, triggering a mass extinction event. These are the fabled gamma-ray bursts, or GRBs. For a few brief seconds, they are the brightest electromagnetic events known to occur in the universe. For a long time, gamma-ray bursts were a complete mystery. We'd see these fleeting, brilliant flashes of high-energy light, but we didn't know what caused them. Thanks to dedicated space telescopes and decades of research, we've pieced together the puzzle. We now know there are two main types. The long bursts, lasting more than 2 seconds, come from hypernovae, the death of massive stars. But what about the short bursts, those lasting less than 2 seconds? Their origin is, if anything, even more dramatic. They are born from a cosmic dance of death between two neutron stars. Neutron stars are the ultra-dense remnants of smaller supernovae. Imagine a star more massive than our sun, crushed into a sphere just a few miles across. A single teaspoon of neutron star material would weigh billions of tons. When two such objects orbit each other in a binary system, they radiate gravitational waves, ripples in the fabric of space-time itself. This process causes them to lose energy, and their orbit slowly decays. They spiral closer and closer together, faster and faster, until they finally collide and merge in an event called a kilonova. This collision is an explosion of epic proportions. It unleashes a torrent of gravitational waves, a short, intense gamma-ray burst. But not all cosmic fireworks are born from a star's death. Sometimes the most violent explosions come from the stars that refuse to die. Let's talk about magmatars. These are a special type of neutron star, the incredibly dense remnants of massive stars. But magmatars are different. They possess magnetic fields hundreds of trillions of times stronger than Earth's. This immense magnetic energy twists and strains the star's crust, building up pressure until it finally cracks. The result? A starquake. This isn't just a tremor. It has an explosive release of energy that can outshine our sun by 100,000 times in a fraction of a second. Imagine an earthquake so powerful it could be felt across the galaxy. That's the terrifying power of a magnetar. They are the most magnetic objects in the known universe, and their tantrums are a sight to behold. and a spectacular glow as heavy elements are created and flung into space. In 2017, for the first time, scientists detected both the gravitational waves and the light from a single kilonova event. It was a landmark moment in astronomy, confirming our theories and opening a new window to the universe. We could finally hear the universe as well as see it. This event also confirmed that these mergers are a primary source of the universe's heaviest elements, like gold and uranium. So we've gone from supernova to hypernovae to the collision of neutron stars. Can it get any more powerful? Yes. We must now venture to the heart of galaxies, where the true monsters lurk, supermassive black holes. These behemoths are millions or even billions of times more massive than our Sun. They are the gravitational anchors of our galaxies, including our own Milky Way. Normally, they're relatively quiet, but sometimes a star or a giant cloud of gas wanders too close. The immense tidal forces of the black hole stretch and shred the unfortunate victim in a process gruesomely named spaghettification. As the stellar material is torn apart, it forms an accretion disk, a swirling vortex of superheated gas spiraling into the black hole. This process isn't an explosion in the traditional sense, but the energy release is astronomical. The friction within the disk heats the material to millions of degrees, causing it to shine brighter than all the stars in the galaxy combined. This is a quasar or a quasi-stellar object. For as long as the fuel lasts, which can be millions of years, the center of the galaxy blazes with unimaginable power, launching jets of energy that can stretch for hundreds of thousands of light years, far beyond the galaxy itself. These jets can influence the evolution of the entire galaxy, triggering or even halting star formation across vast cosmic distances. Now, let's turn our attention to one of the most violent and spectacular events in the cosmos, the death of a star, not by its own doing, but by the hands of a monster. Imagine a star much like our Sun wandering a little too close to a supermassive black hole lurking at the center of a galaxy. The black hole's immense gravity begins to pull on the star, and this pull is stronger on the side of the star facing it. This difference in gravitational force, known as a tidal force, stretches the star, pulling it apart piece by piece. Astronomers call this a tidal disruption event. What follows is an incredible flare of light, brighter than an entire galaxy, as the star's material is shredded and devoured. It's a cosmic feast of epic proportions, giving us a rare glimpse into the extreme physics around these mysterious giants. These events, from the death of a single star to the feeding frenzy of a galactic monster, paint a picture of a universe that is dynamic, violent, and constantly changing. The calm night sky is a lie, a beautiful deception hiding a reality of cataclysmic power. These explosions are not just destructive, they are also creative. They distribute the building blocks of life, forge the elements we depend on, and shape the evolution of galaxies over billions of years. So the next time you gaze at the stars, remember the incredible forces at play. Remember that you are looking at a cosmic battlefield and a cosmic nursery, all at once. The silent darkness holds the secrets to the most powerful explosions in the universe, the very events that made our existence possible. Thank you for joining us on this journey through the cosmos. If you enjoyed this exploration of cosmic power, don't forget to like, subscribe, and hit that notification bell for more deep dives into the wonders of our universe.